So far, we've described the characteristics of a wave visually and looked at its velocity through some medium. In this video, we will provide a quantitative description of a wave by deriving the mathematical equation that describes a wave. For simplicity, we will look at the case of a one-dimensional wave. Consider a wave pulse traveling along a string to the right with a constant velocity v. Let's call this direction the positive x direction. The shape of the pulse can be represented by some function y being equal to function of x and t, where the displacement of the particles that make up the pulse is a function of both its position and of time. The nature of the function f describes the shape of the pulse. This f should not be confused with the frequency. Now let's freeze this traveling pulse at an instant in time. The peak of the pulse happens to lie at the origin of the x-axis. If the pulse is traveling with a velocity v, then after some time interval t, the pulse has displaced a distance given by v times t. So after a time interval t, the wave pulse has been shifted to a new position given by x minus vt. The minus sign indicates how far away the new pulse is from its origin after a time interval while traveling with a speed v. For example, if the speed of this wave was 3 meters per second, then after 1 second of travel, the pulse will be displaced by 3 meters and the new peak will be at 3 meters. After 2 seconds, the new peak will be at 6 meters. Now let's reverse the direction so that the wave is traveling to the left instead. The wave equation is now written as y being a function of x plus vt. So the new position of the pulse after some time t is less than where it was by a distance that it traveled during that time t. Now let's look at a wave created by simple harmonic motion. That is, the shape of the wave is a sinusoid. If we freeze its motion, we can see that the shape of the wave can be described as a sine function where a is the amplitude of the wave. We want a wave to be a function of position, not angle. So we need to convert from a phasor space to a physical space. We know that a wave repeats itself at every wavelength, which represents one full cycle of the wave. And one full cycle is equal to 360 degrees or 2 pi radians. So the ratio of 2 pi over the wavelength gives us the ratio of the angle of its displacement within one cycle. In other words, the angle is equal to the ratio of 2 pi over lambda multiplied by x. The term 2 pi over lambda is called the wave number, which is given the symbol of the lowercase k. This is unfortunate because lowercase k is also used to represent the spring constant, so the two should not be confused. However, context will help determine which definition to use. Now we can substitute our conversion factor in the sine function to give us a wave equation as a function of position. To make the wave travel along the positive x direction, we replace x with x minus vt as previously described. Expanding the inner brackets out gives us y being equal to a sine of kx minus kvt. Recall from the wave speed video that the velocity v is equal to the product of the wavelength and the frequency. The wave number is equal to 2 pi over lambda. The wavelengths cancel out and we're left with kx minus 2 pi ft. Recall also that the angular frequency is equal to 2 pi f, so we can substitute this into our wave equation. So now we have an equation for a sinusoidal wave given by y being equal to a sine of kx minus omega t. The general equation for a one-dimensional traveling wave is given by a sine of kx plus or minus omega t. If the sign inside the bracket is a plus sign, then what direction is the wave moving in? In summary, the equation for a one-dimensional sine wave is given by the amplitude times the sine of the wave number multiplied by position plus or minus the angular frequency multiplied by time. The wave number has the units of per meter and angular frequency has a unit of per second. When the wave is moving in the positive x direction, the sign in the bracket is a negative, and when the wave is moving in the negative x direction, the sign in the bracket is a positive.